Yeah,
You have to log out of the computer now, right?
Yes.
I don't know what that one is. I know this now.
Maybe I could just use this. Yeah.
That's the thing I've been doing at home.
Alright, log out of this one.
How do you like that?
All right, so one thing I want to talk about. Very many of you are going into trig or pre-calculus, right? One little thing that I didn't have show up anywhere in all the stuff we did was something called rationalizing. And this is not the psychological rationalizing. This is kind of like, if I have this, 1 over the square root of 3, for example. Do y'all agree with me that radicals are already kind of not the best thing in the world? Like, is the square root of 3 a nice number?
No.
No. Okay. I personally think it's great, but so not only is the square root of 3 already a little rough, but now I've got it, I'm dividing by the damn thing, correct? So there is a convention. Sort of like if you gave me the answer was 6 over 8, why would I say that's not quite right? 6 over 8. I can simplify it. So it's convention to write the answer as a fraction in lowest terms. So when I have radicals, it is convention to write the answer with no radical on the bottom. So let me ask you this. Why can I not just get rid of the radical? Can I do the square root of 3? No. Why can I do the square root of 9? Why exactly can I do the square root of 9? Well, 3 is a whole number, and I can't do the square root of 3. Oh, the answer is a whole number. Correct. Why?
3 1/2, right?
Say again?
3 1/2.
Okay, square root is cutting something in half, and I can actually cut. So what is 9 made of? If you break 9 up, it's 2 3s. And so a square root can be done if I have 2 of the same thing inside, correct?
Mm-hmm.
Square root of 25 I can do because it's got a 5 and a 5. Do you guys kind of follow?
Yeah.
So if I would have had more time with radicals, I could have taught you a whole idea like when I have a cube root, I'm looking for groups of 3 of the same thing. So can I do the cube root of 8? Yes, because 8 is 2 times 2 times 2. And a cube root is looking for groups of 3 of the same thing. Okay, maybe. So let me ask you this. If you had the power, if you were math god, what would you give the bottom so that you could do the square root? What's it missing? It's only got 1 3. If I could just give it, if I could just somehow give it
2 3.
1 more 3. Do you guys agree with me? If I could just give the poor little dude 1 more 3, it could be done. Yes?
Yeah.
Okay. And you're all like, I can't do that shit, Jeff. But yes, I can. So, and by the way, little side note. 3 times square root of 3. Can I make that the square root of 9? Can I combine those? No. They have to be in the same radical. Then I can combine them, yes? What's a whole 3 times a whole 3?
9.
A whole 9. What's half of 3 times half of 3? Half of 9. Does that make sense?
Mm-hmm.
I can only multiply things that have the same radical. So if I want to give this guy another 3, I have to do it like this. If I multiply the bottom by rad 3, what does this become? Square root of 9, which is 3. Hey, then the bottom won't have a radical. Now, what's fractions require from me to make this legal?
You have to do it to the top.
I have to do it to the top also. So then on the top, I'm going to do the top. 1 times rad 3 is rad 3. Whew. And on the bottom, you don't even have to do this. Now, square root of 3 times square root of 3 is square root of 9, correct? Mm-hmm. Half of 3 times half of 3 is a whole 3 is a better way to look at it. So square root of 3 times square root of 3 is 3. What's the square root of 7 times the square root of 7?
7.
What's the square root of 11.3 times the square root of 11.3?
11.3.
Yeah, square root of pi times square root of pi. And you're like, we got it, John. So half of a number times the other half of the number makes a whole number. Okay. So this would become 3. This is what's called rationalization. I have rationalized the bottom. Why do we call it that weird-ass thing? Because I've made the bottom become a rational number. Irrational numbers are like pi, square root of 3, the funky ass numbers where the decimals never stop and they have no pattern, correct? You guys kind of with me? Is this coming back? Rational numbers are decimals with a pattern or terminating decimals. Because I can write it as a fraction is a ratio, that's why we call them rational numbers. Okay. Crazy shit. So this is going to be, believe it or not, this little skill is going to be huge in trig. And it's going to be huge in other things too, but trig especially. You're going to get stuff like 1 over rad 2. What would you do to that to make it better? Multiply the bottom and the top by rad 2. So it becomes rad 2 over 2. Yay! So when you take trig, when you see rad 2 over 2, go, oh yeah, Jeff, I got you. You're also going to see this shit too. When you see that shit, you go, oh yeah, that Jeff got. Okay. Or say whatever you want to. I'm not going to put words in my mouth. Okay. All right. So that's one skill I wanted to talk about. Let me throw this at you. What about 2 over the cube root of 4? Just to really, why not? If a square root needs 2 things in it, a cube root needs 3. Am I missing 2 4s on the bottom then? Yeah. Is there a better way to look at what is 4 already? Break it up. 2 times 2. I already have 2 2s. How many more 2s do I need?
1 more.
Cube root needs how many things in it? 3. What do I mean by that? Square root of 9 is 3 because it has 2 9s. Cube root of 27 is 3 because it has 3 3s. I need 3 things. 4 is 2 times 2. I already have 2 2s. I just need 1 more 2 and it makes 3. I like it. So if I multiply by the cube root of 2, I got 2 cube root of 2 over, now this one I'm okay with. If you do this, what's 4 times 2? That's crazy, Jeff. And what's the cube root of 8? And then these 2 2s cancel. So I get the cube root of 2. Crazy shit. Okay. You guys kind of with me? This is a weird little thing you don't see very often, but just to kind of show you, this is kind of big in trigonometry especially, because you're going to be doing this a lot in trigonometry. And you guys going to take, how many of you guys taking pre-calc again? 176. And 170. Anybody taking 170? Okay. All right. Trig. What have you heard about trig?
Scared.
Scared, okay. Unit circle, sine, cosine. Sine waves you've seen before. Anybody do any playing musical instruments? Ever looked at a oscilloscope or something that's got the sine wave going? Yeah? Okay. And if you turn it into too much, the gain, you got the gain. Say again? Yeah, triangle wave, a square wave. I love it. Kick ass. Sorry. If you don't have to take trig, I apologize. You're fine. If you're taking college algebra, you're still going to have to be able to do this. Okay. Now, let me throw it open to you guys. Is there any topic you want to revisit or that you are in your head and you want to talk about it because we haven't talked about it yet? Yes?
Can we briefly go over like the rules of fractions? Like when you're multiplying
Oh,
them,
yeah.
you're dividing them, and you have
Okay.
a whole number and then a fraction, all
So
that
real quick,
stuff.
the thing that gets people out, okay, so multiplying fractions, you just multiply across. And to be really honest, watch this. What's 3 times 7? Didn't we multiply, and what's the bottom?
1.
1. So didn't we do 3 times 7 is 21, 1 times 1 is 1. Didn't we do that? We already do that. So here's a really cool way to look at this. So this would be 21 over 20. Is that cool? One way to look at this is 1/4 would be, I can take something and cut it into 4 parts, right? Is that cool? So 1/2 of 1/4, let me cut that in half. And how much is this piece right there then? 1/8. There. So you multiply across. 1 times 1 is 1. 2 times 4 is 8. It's crazy. So there's actually visual ways to represent this. One class I teach is math for elementary teachers. So we talk about how to teach fractions. It's really cool. We use like little manipulatives that all represent different fractions. You put them together, you get the bigger one. If you put 1/3, 1/3, 1/3, you get 1 whole. It's amazing. Okay. Yeah, I like that. So, ooh. Now, the thing that gets people down normally, because multiplying is pretty straightforward. Let me say this. What's the only time in the frickin' universe that you will cross multiply? There's only one time, and that is when you have an equation. Then you could cross multiply, right? There are situations where you can do something related to cross multiplication because you're being all clever, but you don't want to do that shit if you're not comfortable enough to do it. This is the one time cross multiplication directly works. Are you guys at all with me?
Yeah, I mean, I just like.
Do you remember cross multiplication? No. Okay, so real quick. Let me make this a little more exciting. Let me do this. Okay. Ooh, that's so exciting, Jeff. What sucks about this equation is the fractions, yes? Do y'all agree with me that if I multiply both sides by 7, this 7 will cancel?
Yeah.
So I'm getting rid of my fractions, yes? So what else do I want to multiply by?
Okay.
X. Then it cancels here, yes? Do you see how it looks like the 7 just went up there? Do you see that? Do you see how it looks like the X just went up there? So therefore we made... Oh, sorry. Everybody good? I like that. That's why we made a shortcut out of this. The X looks like it just comes up, so let me just take it up. The 7 looks like it just goes up, so let me just take it up. That's cross multiplication. It's a shortcut. Okay, I like it. Sweet. Now, I want to say that because in a lot of fraction problems, students will do cross multiplication at the wrong times. The only time you directly do it is if you have an equation with 2 fractions in it. Okay. So real quick, what about, let me show you the real idea behind this. We've talked about this. Some of you guys know what to do. What do you do? To do this division problem, what would you do? Nope. So real quick. What is x plus x squared? They're not what? They're not like terms, correct?
Yeah.
All right.
So I cannot add x and x squared. Is everybody with me? Well, what is x times x squared? X third. See how multiplication is not as restrictive as addition, subtraction, right? So when I'm adding, subtracting fractions, I need like denominators to make them like terms. Do you all agree with me that 5 things minus 4 things is 1 thing? So 5/8 minus 4/8 is 1/8. Whatever the thing is, I can just subtract the damn things, yes? You guys with me? But 5/8 minus 1/3, shit. Those aren't like terms. So finding LCD is just finding like terms. Are you at all with me? When I multiply divide, I do not need a like denominator because division multiplication is not as restrictive as addition subtraction. Okay, all I hit. Now, let me ask this again. Does anyone know the official first step to do this division?
Flip it.
You multiply by the reciprocal. Does anyone know why? Does anyone know why? Does anyone want to know why? Okay.
Yeah.
So I am going to show you the kind of disgusting work to show why the shortcut works. Multiplying by the reciprocal is a shortcut. So what I'm about to do, dear God, never do it. You with me? So what I'm about to write is not me saying this is how you do it. What I'm about to write is me saying this is why the shortcut works, and dear God, use the shortcut. Are you with me? Because I start to do a derivation, and students are like, why are you making this so hard? And I'm like, I'm trying to prove why the easy way works. Okay. So I could rewrite this. How do you rewrite like 2 divided by 3? What's another way to write 2 divided by 3? 2 over 3, yes? So guess what I'm going to do? I'm going to write 3/4 over 5/2. How excited are you about that? This is what dad joke math boy Jeff says is a fracception. It's a fraction within a fraction, right? If you've never seen Inception, I guess it goes over your head, but that's all right. Let's go to sleep and wake up. Go to sleep. All right. This sucks. Can somebody tell me what is the absolute best number to have in the denominator? 1. Do you agree with me? If the bottom is 1, that kicks ass. 7 over 1, you're like, oh, you're 7. Thank you. Yes? Is our bottom 1?
No.
Damn it! So, I'm allowed to multiply top and bottom by anything I want to except 0, correct?
Mhm.
What would you multiply this by to make it become 1? 2 over 5. If I multiply by 2 and I have a 5 underneath, won't they both cancel, make the bottom 1? You guys see that? So if I multiply the bottom by 2/5, I better multiply the top by 2/5. This becomes 1. I just made that become this. So instead of doing all that shit, we just made a shortcut. When I divide fractions, you flip the second dude. What is it? Keep, change, flip, or something like that? Keep, change, flip? Sure. I'm not the biggest fan of those kind of things, but that's fine to know. I'd much rather you just understand why it makes sense to do this.
It's always the second?
Always the second dude. Because he's the one that would end up on the bottom. So he's the one that's a pain in our ass. He's the one we got to take care of. Okay, maybe. That is why you reciprocate. That's why you multiply by the reciprocal. I like it. Did you have any other specific fraction questions?
The one earlier where it was like 1/2 over 1 or something.
1 over 1/2.
Yeah.
Yeah, so now this problem is not that bad. This is 1 divided by 1/2. How do I divide fractions?
It's going to be 1 by 2.
You flip it.
1 times 2? Done.
Okay.
I was showing some of you guys the physical meaning behind this. If I have 1, how many 1/2s fit in 1? 2. That's what the physical meaning is behind that, right? Because if I have 6, how many 2s fit in 6? 3. 6 divided by 2 is 3. That's the physical interpretation of dividing. So how many 1/2s fit in 1? 2 1/2s fit in 1. That's why the freaking answer is 2. It makes sense. Hopefully. Okay. You guys kind of with me? Fractions are nowhere near as bad as what we think they are. I just think we don't get enough practice with them anymore. I think high schools are using calculators and even like before that, a little too soon. But oh well, I'm just an old math guy. What do I know? All right, guys. Any more about fractions or anything else that's like burning in your brain? Like, why didn't we talk about this thing? Are you guys like, I'm so mathed out, Jeff, man? Anything else?
No, I mean stat stuff, but I think I'm on one in stats.
The thing I was going to do for you, don't let me forget. Does anyone else need to take stats eventually? Anybody? Yeah? One thing I like to give my students, and I try to make them understand, is not to memorize. I give them the Greek letters. The one big thing in statistics that gets students down is the letters, the variables. A lot of them are Greek letters. So what I try to do is before the semester starts, I say, look at these Greek letters. You don't have to memorize them, just kind of get used to them. Just trying to look them over, because you're going to see sigma, and you're going to see mu, and all this kind of weird stuff. I like mu. Mu is like the French cow. Mu?
I
Yes.
took statistics. Something that really helped me, especially in the later half, is I actually invested in erasable colored pens,
Yeah.
which actually really helps because like once you get to the higher ones, you have I think I was working up to 5 or 6 or 7 variables, so it really keeps track
Yeah.
of it.
So what gets people down in statistics is the other variables. There's kind of big equations that you have to use. But there are no word problems. People always think there's word problems.
Yeah, that's what I've been-
A word problem is not a problem that has words. A word problem is one where you develop your own formula for each problem. A train leaves Wyoming going east, 60 miles an hour. Another train is going this way. And how long until they crash? And you got to set up your own equation from nothing, yes? That is a word problem. The problems you see in statistics are pick the right formula, plug shit in. Now, I'm not saying it's going to be easy, because that's kind of hard, is to know the concept well enough so you know which formula to use. But it really is then just plug the numbers in the right place. That really is what it is. There's no word problems. Yeah.
Can you go over
Polynomials, what about them?
adding and subtracting?
Oh, give me a polynomial, somebody.
2.
That's true, I love it, John. I was waiting to see where my smart ass is at 11. That's not a insult, by the way. Yeah, you're good. 2 is a polynomial. So let me, what you got? Oh, you're looking something up, dude. polynomial is, so all a polynomial is every every variable in it has to be to a whole number power. That's all a polynomial is. So is 2 a polynomial? Yes. Every variable you see, is it raised to a whole number power? Yes. Do you see any variables? Are there any variables in this expression? Do you see any x's, y's, a's, b's, c's?
No.
It's just a number. So every variable you see, is it raised to a whole number power? Yes. Good. What about 3x plus 1? Is every variable raised to a whole number power? What's a whole number, by the way? Let me make sure everybody's with me. A 1 is a whole power. Well, what are whole powers? I'm sorry, whole numbers.
No decimals.
No decimals. Let's say this. It's 1, 2, 3, 4, but they add the number 0 because the number 0 is the one that looks like a whole. So that's why it's not y, but that's a way to remember. That's whole numbers. 0, 1, 2, 3, 4 forever. So no negatives, no fractional powers, right? So is this a polynomial?
No.
No. Get out of here. It's not a polynomial.
I'm giving you your 5 minutes.
Oh, what's up? I'm sorry.
Oh, this is 5 till noon.
No, I see. Yeah, yeah.
I just want to
Trust
remind you
me.
we have a special guest today.
No, I'm with you. I'm with you.
Okay.
And
Yeah, yeah.
before you let them go, the people who haven't enrolled.
Yes, yes,
you
yes.
Give them this, come fill the top. and
Yeah,
come
we
back
all
again.
logged into Canvas, and I've identified a few that didn't see our course. So,
Okay.
Haley, you definitely need one of those forms.
Earlier in the
We
week.
need some form, just fill out the top part, and then give it to Jeff, and then he'll fill out the rest and turn it in.
So that's polynomial, but the 3x.
That is because the only variable has a power, a whole number power. Yeah.
But if it had any other.
If there's any variable that has something that's not a whole number power, a fraction power, a negative number power, that's not a polynomial. And the reason we identify polynomials is because they're nice. We call them smooth. They don't do any freaky shit. So this would be a graph of a polynomial. That's a little freaky. No, sorry. The graph of a polynomial kind of looks like the Loch Ness monster sometimes, right? It doesn't have any. So would you agree that if I saw a graph like this, it's a little freaky?
Yeah.
All right, that's not a polynomial. There's something really freaky going on there. It's not a polynomial. So polynomial is one that doesn't like teleport somewhere else. Like if I had a graph like this, and then it teleports up there.
What is that?
Huh?
What is that?
This is what's called a piecewise function. It's kind of like, do you see how this piece and this piece are two different things? So math people being very creative with their names, we call it piecewise. Not to be confused with pennywise, that doesn't float down here, all that stuff. Okay. I think that might be enough bad jokes for me. So let's do this. We got 5 minutes. So by the way, just to remind you guys, we have a raffle. I'll just tell you this. Whoever wins the raffle is going to win a graphing calculator. We have the president coming by to say hi, to show our support. Huh? Not the. Yeah, we got Joe Biden couldn't make it. Kamala, I thought Kamala was going to come, but no. I'm not going to talk to the other guy. All right. All right. Even if you could come, I'd say nope. So let's do this. I want to make sure we don't miss out. I'm going to go check and make sure if lunch is kind of like ready. And then we can kind of go for early lunch, right? For once. Like it's about